Today's lesson is moving past just calculating slope and writing full equations of lines in different forms and just a little bit of graphing. So the three forms we're going to focus on are slope-intercept, point-slope, and standard. Slope-intercept by far is the form that most people remember from Algebra 1, and that's the y equals mx plus b. And the reason it's called that is because you've got your slope and the b is your intercept. So the m is the slope and the b is the y-intercept. Okay, hence the name slope-intercept form. So it's really useful when you know your y-intercept. Oftentimes we take point-slope and convert it to slope-intercept, and we will see several examples today. All right, point-slope form, y minus y1 equals m times x minus x1. Okay, and then if we labeled what we have here, of course, there's your slope. But then the x1 and y1 here is your point. Okay, so any ordered pair, we'll call it x1 comma y1, can be plugged in for those variables, and that would be a point-slope equation. So this again is useful when I don't know my y-intercept. I mean, you can use it if you know your y-intercept, but it's a little quicker just to go straight to slope-intercept form. But we will use this a lot because most of the time we don't know the y-intercept. All right, standard form is going to be ax plus by equals c. So most functions have a standard form. This is the one for linear. One requirement is a and b cannot be equal to 0. So I'm going to put here a comma b equals not 0. If one of those is 0, the whole term goes away, and therefore it's not standard form. A, b, and c are also integers. We will write them as whole numbers versus leaving them as fractions or decimals. All right, well, let's do this first example here. Write the equation of the line. I'm given a slope and I'm given a y-intercept. So this we can jump straight to y equals mx plus b. Here would be our m and our b. So our equation would read y equals 4x plus 6. Okay? All right, number 2, write the equation of the line. The slope is 2/3 and the point is 4, 7. So I don't know the y-intercept, so I'm going to jump to point-slope form first. So let's write that down. Y minus y1 equals m times x minus x1. Okay, so I'm going to plug in, or I'm going to call 4 as x1, 7 as y1. So I'm going to plug that in here with colors so you can see that a little easier. So y minus y1 is the 7 equals m. Of course, we'll plug in the 2/3 times x minus, and the x1 is 4. Okay. So if either x1 or y1 was negative, well, can you see how the format is minus, but it would end up becoming plus in my equation because it's going to be a negative. So we want to take this and always convert it to slope-intercept form. All right, so we can do rearranging here in this equation. So I want to go ahead and distribute 2/3 into my parentheses. Okay, so I'm going to distribute that in. So I'm going to kind of move over here. So y minus 7 equals 2/3 x, and then 2/3 times negative 4. I'm going to let the calculator help me with that. So if you have a calculator like this one, or really most scientific calculators, I don't want to write things as rounded decimals, so I usually leave them in fractional form. So 2/3 times negative 4. Now that's a mixed number, negative 2 and 2/3. We normally like improper fractions. Once we get past, into Algebra 1 and beyond, we tend to leave things in improper. So we can do the improper by hand. I can take the 2 right here, multiply by 3 plus 2, or you also have a key right here above the ABC key. See how it says ABC arrow DE? That's a toggle back and forth between mixed to improper. So I can leave my answer right there, and I have to hit second because it's above the fraction key. And so see how it's saying take the answer and switch it. So negative 8/3. And it just goes back and forth. So every time I activate that menu, it calculates that amount. So minus 8/3. Okay. And then now I need to get y all by itself, add 7. So you're going to have to add 7 to your 8/3. So y equals 2/3 x. And I'm going to take this and I'm going to add in 7. 13/3 plus 13/3. Okay. Now, you can certainly do your fractions by hand. That is just fine. You'd have to get a common denominator over to the side and then just work through your math that way. Okay, so I've got the equation of the line. Here's my, if I wanted to just stop at point slope, or maybe the directions said write it in point slope form, I would do this. But on all these examples, I'm going to convert to slope intercept because I want you to get practice on that. Okay, let's keep going. Number 3, write an equation of the line passing through the point 3, 4 that is parallel to the line with the equation of y equals negative 4x plus 5. Okay, so I have a line. I want a second line going through this point that is parallel to the first line. So when you have lines that are parallel, you need to think about, well, what does that mean? What properties of the equation do I need? So what you need to think about is if you want a line parallel to this one, you need it to have the same slope. Okay, so I'm going to write over here to the side, same slope. Okay, so that's kind of what should pop into your mind. All right, I need the same slope. Well, the next question is, well, what is the slope of this equation? So I can tell this is in slope-intercept form. So the slope here is the m in the equation, so negative 4. So I'm going to write a new equation, a second line, with a slope of negative 4 going through this point. Okay, so I am ready to recreate really what I did up here. I have a point, I have the slope. I'm going to start with point slope form. So y minus y1 equals m times x minus x1, plug in x1, y1, and m. So y minus the 4 equals m of negative 4 times x minus the 3. Okay, and so now we just, I want us to always convert to slope-intercept. So let's distribute. So y minus 4 equals, so that would be negative 4x. Negative 4 and negative 3 is positive 12. And then we need to add the 4 over. So that gives me y equals negative 4x. 12 plus 4 is 16. Okay. So I have a new line. So what I want you to see is equation number 1, negative 4x plus 5. Equation number 2, negative 4x plus 16. They are parallel, they have the same slope, but they're crossing at different locations on the y-axis. Okay, so they are parallel to each other. Okay, I want you to try number 4. So will you pause this video, read number 4, and then come on back and check your answer. Okay, so perpendicular means the two lines have opposite reciprocal slope. If this is a slope of 4, I'm going to write here that my perpendicular m is a negative 1/4. So that's what I'm going to use in my equation. And then here's my x1, y1. So I'm going to do y minus y1 equals m times x minus x1. So I have y minus negative 3. So if I do y minus negative 3, see how it turns into plus 3. Y minus negative 3, my double negatives would cancel out to be positive, equals the m, my new m, of negative 1/4 times x minus 6. Okay, distribute in. y plus 3 equals negative 1/4 x minus, and again, if you want to use your calculator, you can. If you want to do it in your head, that's fine, times negative 6. 1 1/2, which is 3/2. So minus 3/2. And then now I want to take away that 3. Okay, so minus 3 minus 3. Okay, so I'm going to take my negative 3/2 minus 3. I'm going to have a negative 3/2. So that's basically a 1.5. So if you have negative 1.5 and you take away 3, you had actually I wrote down negative. This is a negative times a negative is a positive. I think I even had a positive on my screen here. Yeah, and I wrote down negative. Okay, backing up, I have positive 3/2 minus 3 gave me a negative 3/2. All right, so my equation, y equals negative 1/4 x minus 3/2. And so I always want to reduce these fractions down. Back here at this step, I had negative 1/4 times negative 6. I could have left it as a positive 6/4, but that reduced down. So if you are doing it by hand, that's fine. I could have waited to reduce it down at the end, but my calculator helps me do that as well. Okay, well, I'm going to stop this video here, and then in the next video, we are going to move on to standard form back here and just look at a couple more examples.